We're going to do the exact same thing that we did with our previous problem, but now we're going to use an angle of 30 degrees in standard position. So the first thing I'm going to do is kind of estimate where 30 degrees would go. It would be about a third of the way up the circle on the first quadrant. And I'm going to draw my triangle. So this would be my 30-degree angle. And then I'm going to drop down my side to get the right angle. Now again, we're talking about the unit circle, so our radius is going to be 1, which is the hypotenuse of our triangle. So I want to go through that whole process again that we did with the 45, 45, 90 triangle, where we put in all of the labels and then tried to figure out what the other two sides would be if our radius has to be 1. So the first thing I'm going to do is write in just our regular angles. So I'm going to make this 30 and this 60. Doesn't really matter which is which. Across from the 30-degree angle, our side is equal to x. Across from the 60-degree angle is x root 3. So those are the two legs that make up the triangle, the two legs that make the right angle. And then our hypotenuse is 2x. So now what I'm going to do is set the radius equal to 1. And the radius, by the way, in our triangle is the same as the hypotenuse. So I'm going to say that 2x equals 1. And then I'm going to draw that equation over here. So now what I'm going to do to solve for x is divide by 2. So I get that x is 1/2. So what that means is that this side here is 1/2. And then this side here, I could write it as 1/2 square root 3. That would be fine. But the way you're going to see it written is like the square root of 3 and the 1 are getting multiplied together in the numerator. So it's going to look like this. It's going to look like the square root of 3 over 2. So the square root of 3 is on the top, and then you have your 2 for the denominator from the half. So these are the two sides that we're going to use for our x and for our y. So I'm going to go ahead and write those in on our triangle over here. So our x value, meaning on the x-axis, is going to be the square root of 3 over 2. And then our y value is going to be 1/2. And I'm doing that by just looking at this triangle here. I'm just basically copying down the same numbers that are in light blue and matching them up with the same sides on our triangle that's part of the unit circle. Now what I want to do is label all of our sides. So remember that our radius, that's the hypotenuse of our triangle, that's equal to 1. That's the whole reason we're doing all of this manipulating with the sides of the triangle. The x value is the one that's on the x-axis, and then the vertical value would be your y value. So I have everything set up. Again, I'm going to go through and do all my ratios, which hopefully you have memorized. So we're going to have y over r, x over r, y over x, and then the reciprocals, you just flip them upside down. So if you are at the point where you are not yet memorized on all of these ratios, it's really important that you write them down every single time you do a problem. It really will help you to memorize them if you just continue to write them down. So now we have to figure out what all of our ratios are. So I'm going to do, for sine of 30, we're going to do y over r. So that would be 1/2 over 1. Anything divided by 1 is just the same thing. So 1/2 divided by 1 is just 1/2. For the cosine of 30 degrees, that would be x over r, so I would have the square root of 3 over 2 over 1. And again, anything divided by 1 is just itself, so the cosine of 30 is the square root of 3 over 2. And then the tangent of 30 would be y over x. So this is where things are going to get a little bit complicated. So I have y, which is 1/2, over x, which is the square root of 3 over 2. So here's one of those complex fractions where I have a fraction on top of a fraction. So I'm going to take my top fraction, which is 1/2, and I'm going to multiply by the reciprocal of the bottom fraction. When I multiply straight across, I'm going to get 1 times 2 in my numerator, and then 2 times the square root of 3 in the denominator. I have to rationalize the denominator, so I'm going to multiply by the square root of 3 over the square root of 3. So I'm going to end up with 2 times the square root of 3, and then the square root of 3 times itself is 3, and 2 times 3 is 6. And then there's one more thing I can do, which is to simplify 2 over 6. That would reduce to 1 over 3. So my final answer here would be the square root of 3 over 3. All right, now I just want to make sure I re-emphasize the fact that our sine value, which is 1/2, is equal to our y value. So if I wanted to make this into an ordered pair, for this point here, 1/2 would be our y value, which is also our sine value. And then our cosine value, which is the square root of 3/2, is equal to our x value. So the ordered pair here is the same as whatever the cosine of theta, or actually I could put in 30 since we're talking about a specific angle. So the cosine of 30 would be the square root of 3/2, and the sine of 30 is 1/2. All right, let's go over to our reciprocal function. So we're going to take our answers from the main three functions, and we're just going to flip them upside down. So if I take cosecant, that would be the reciprocal of sine. If I flip 1/2, it would be 2/1. But anytime you have 1 in your denominator, you don't have to write it. So it would just be equal to 2. For secant, I would have 2 over the square root of 3. I have to rationalize because I can't leave the square root of 3 in the denominator. So I would have 2 square root 3 in the numerator, and then the denominator just turns into a plain 3. And then for my last one, I'm going to take the square root of 3/3 and flip it upside down. Now, I think there's an easier way to do this where it would be a little bit less work, but I think that sometimes it's easier just to follow the same procedure rather than save yourself a shortcut. So I'm going to go ahead and just flip it upside down, even though it's going to require me to rationalize. Hopefully rationalizing doesn't seem so bad at this point. So the numerator is 3 square root 3, denominator is 3. The 3's just cancel each other out, and I end up with the square root of 3 as my answer for cotangent. Now, like I mentioned in the previous slide, we're talking about a 30-degree angle here. That's our theta. That is the exact same thing as pi over 6 radians. So 30 degrees is the same as pi over 6 radians. So if any question we could ask you to identify what is the cosine of 30 degrees, we could also say what is the cosine of pi over 6 degrees, and you would need to know that those two angles are equivalent. We're now going to do the exact same process with 60 degrees. You'll notice that we don't have a triangle here for us to kind of figure out, and that's because it's the exact same triangle that we just did for 30 degrees. The only difference is that the two legs of the triangles are going to flip-flop. So if I wanted to draw a 60-degree angle, that would be somewhere around here. So I'm going to connect the origin to my point here, and then draw a straight line down to make my right triangle. So this angle right here at the origin would be my 60-degree angle. Remember that when we're talking about the unit circle, r is always equal to 1. And then if you remember from the previous slide, we figured out that the side that's across from the 60-degree angle is going to be the square root of 3/2, and the side across from our 30-degree angle is going to be 1/2. So it's the exact same sides, it's just we took them and we flipped the places where they are because the triangle kind of flipped. Now the 60-degree angle is at the origin instead of the 30-degree angle. So I still have the same information, it's just flip-flopped. This 1 represents my r, 1/2 represents x, and the square root of 3/2 represents y. We're going to do the exact same thing where we fill in our ratios and then we do some simplifying. So, and actually before I do that, I just want to make sure I mention this ordered pair right here would be an x and a y, so it would be saying 1/2 comma square root of 3/2. That would be our ordered pair that represents. And remember also that the cosine of our angle, so cosine of 60 would be 1/2, and then the sine of 60 would be equal to the square root of 3/2, which you will see when we actually go through and do all the ratios. So I'm going to fill in all the ratios, and again, if you don't have these memorized yet, I would really emphasize that you should try to write these down every time you do a problem. Okay, so I've got my ratios written down. For the sine of 60, it's going to be y over r. Y is the square root of 3/2, r is 1, so I only have to write the square root of 3/2. We don't have to write the 1. Okay, for the cosine, we're going to do almost the same thing, but it's x over r, so it's 1/2 over 1, which is just 1/2. And then for the tangent, it's going to be y over x. So this one is going to require a little bit of work here. So we're going to have the square root of 3/2 over 1/2. In order to simplify that, we're going to do the square root of 3/2 times the reciprocal of 1/2, which is 2 over 1. Now I can multiply this straight across, but kind of a shortcut that you may have noticed is if I have the same thing in the numerator and denominator, I can cancel them out. So this 2 here and this 2 here cancel each other out. And all I have left is the square root of 3 over 1, but I don't have to write the 1 because it's in the denominator. So final answer for the tangent of 60 is the square root of 3. Now I'm going to take all my answers and flip them, and we'll simplify if we have to. So for cosecant, we would take the sine answer and we would flip it upside down. This one we do have to rationalize because we end up with a radical in the denominator. So I would have 2 square root 3 over 3, and that would be my final answer. There's nothing I can simplify. If I wanted to flip around the cosine of 60, it would be 2 over 1, but I don't need the 1 because it's in the denominator. So the secant of 60 is just 2. And then for cotangent, I'm going to take my answer for tangent and flip it. Now, right now, my answer for tangent is just, it's not a whole number, but it's not part of a fraction. So you can think of it as the square root of 3 over 1, and that way when I flip it, you can see both parts. This one is going to require rationalizing because there's a radical in the denominator. So I would have the square root of 3 on the top. I don't need to write the 1. And then my denominator would just be 3. So that would be our answer for cotangent. Now, one thing you may have noticed, if you're being really observant, is when we did the sine of 30 and the cosecant of 30, those answers are the same as the cosine and secant of 60. And that's not a coincidence. When we really talk about the unit circle all together as one big piece, you're going to see that it's the same pattern over and over again. Everything just kind of flip-flops and changes positions, but it is all the same information. The last thing I want to mention is down here where it talks about 60 degrees being the same as pi over 3 radians. So you're expected to know that 60 degrees and pi over 3 radians are the same angle. So we could ask you to find the cosine of 60, or we could ask you to find the cosine of pi over 3, and you need to know that those two things are the same.